Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, so today's video is for our lecture, week 3. So we will continue our chapter 2, frequency distribution and graph for part 3. So, if you still remember, last week we already learned about the graph. The basic one is the histogram, a frequency polygon, and also ogive. Okay, these three graphs use the boundaries. Okay, for the x-axis and also meanwhile for the y-axis we use the frequency and also cumulative frequency. Okay, that is all about the histogram, frequency polygon, and also ogive. Okay, and this week we continue other graphs. There are 5 other graphs that we will learn today. So the first one is box plot, or the other name is box and whiskers plot. So sama ada kita guna nama box plot ke box and whiskers plot ke, you have to know that they are the same. And then we have Pareto chart, time series graph. Okay, so time series graph, it looks like the frequency polygon, but it is not frequency polygon. And then we have pie chart, okay, and stem and leaf plot. Saya rasa tak ada masalah untuk awak kenal, okay, pie chart and also stem and leaf plot. Okay, but then we will learn all these five graphs today. Okay, we will see how what is the step, what are the steps that you have to follow when you want to build this graph, okay, based on your data. Okay, so the first one is box plot. So what is box plot? A box plot is a graph of a data, okay, obtained by drawing horizontal line from the minimum data value to Q1, drawing a horizontal line from the Q3 to the maximum data value, and drawing a box whose vertical side pass through Q1 and Q3 with a vertical line inside the box passing through the median or the Q. Okay, so it means that, okay, this box plot use 5 summary number. Okay, what is that? So with the 5 number summary, 5 number summary is the minimum and maximum value, and also the 3 quartile, okay, Q1, median, and Q3. That is the 5 number summary. So when you have to construct the box plot, you have to make sure that you have the these 5 summary, 5 number summary. Okay, the 5 value. So you have maximum, minimum, Q1, Q2. Okay, Q2 is a median, or and Q3. Okay, where you have these 5 values, you can construct the box plot. Okay, next. Okay, draw a horizontal axis with a scale such that it includes the maximum and minimum data values. Okay, next you have to draw a box whose vertical sides go through Q1 and Q3, and draw a vertical line through the median. So draw a line from the minimum data value to the left side of the box, and a line from the maximum data value to the right side of the box. Okay, this is how this is how the box plot looks like. Okay, and this is the value of minimum, and this is the value for maximum. So the minimum value go to the quartile 1, okay, Q1, and then the max value goes to quartile, okay, Q3, and then the middle one is the median value. So with the Q1 to Q3 is the interquartile range. This one, okay, the line is called whisker. That's why some people use the name of box and whisker plot. Okay, so in this note I include example for each type of graph. Okay, how the question looks like and how to construct the graph. So the first example is for the box plot. So you have given a collection of numbers, okay, number of meteorites, okay, found in 10 state of US. So you have to construct the a box plot. Okay, when you have this ungroup data, kalau awak ingat balik, step dia memang you have to arrange this data. So always arrange in ascending order. Okay, then for this ungroup data, you have to find the median. So the median, okay, so the location is the total n plus 1 divided by 2. Okay, when you get the value, it shows that, okay, the value is 5.5. So kalau tengok total number, okay, total n kita ada 10 number kat sini. So dia 5.5 ni antara location dia antara 78 dengan 89 ni. So okay, you have to add these two number and then divide by 2 to get the exact value of the median. Okay, that is for median. Okay, then we have to find Q1. Okay, awak dah tahu, okay, tengah-tengah dekat sini. Okay, tengah-tengah adalah dekat sini. Maksudnya bahagian yang hadapan akan 5 yang di hadapan akan jadi Q1 kita. Okay, first bahagian depan, and then untuk cari Q3 kita guna yang 5 bahagian 5 number lagi yang bahagian kanan. So untuk cari Q1, kita ambil 5 number yang di hadapan iaitu 30, 39, 47, 48 and 78. So from the 5 numbers, you see where is the middle number? 47. So 47 is our Q1 for this case. So next step, you have to find a Q3. So we get the second part of the 5 number. So 89, 138, 164, 215 and 296. Again, you have to find the middle number for this set. Okay, so this is Q3. So tadi dah dapat dah, median dah ada, median dah ada, Q1 dah ada, Q3 dah ada. So minimum kita dah tahu 30, maximum kita dah tahu 296. So bila dah ada 5 information tu, kita bolehlah lakukan kita punya bolehlah construct kita punya box plot tadi. Okay, so kata draw a scale for the data on x-axis, locate the lowest value Q1, median and Q3 and the highest value on the scale. Draw a box around Q1 and Q3, draw a vertical line through the median and connect the upper value and the lower value to the box. Okay, why? Okay, if you see this figure, you can see that, okay, the distance between the Q3 and the maximum value is quite far. Rather than, okay, the Q1 value with the minimum value. So, awak kena betul-betul tengoklah. Janganlah jarak dia kat sini jauh tapi awak lukis terlalu dekat pula dia punya vertical line, dia punya apa? Horizontal line. Okay, you kena tengok betul-betul. Macam mana you nak placekan jarak antara the max value and with the Q3 and the minimum value with the Q1. Okay, if you can see the distribution is somewhat positively skewed. Okay, if you if you want to explore your Microsoft Excel, you can construct this what we call this box plot using your Microsoft Excel. Okay, just key in the set of data or the set of these values, and then okay, you can find on in your Microsoft Excel box and whiskers plot, I think. Okay, so this is how it looks like when okay we use Microsoft Excel to find our box plot. Okay, the values is a bit different. Okay, because they used formulas. Okay, for to identify the Q1 median and Q3 instead of this one. Okay, kita hanya cari berdasarkan location kita sahaja. Okay, ada sedikit perbezaan dekat sini lah. Okay. Apa yang kita peroleh bila kita gunakan box plot ni? Okay. If the median is near the center of the box, the distribution is approximately symmetric. Okay, the second one, if the median falls to the left of the center of the box, the distribution is positively skewed. Okay, if the median falls to the right of the center, so the distribution is negatively skewed. Okay, and the second one is A, if the lines are about the same length, the distribution is approximately symmetric. So if the right line is larger than the left line, the distribution is positively skewed. So if the left line is larger than the right line, so the distribution is negatively skewed. Okay, so kalau awak tengok yang ini, kenapa dia kata it is positively skewed? Sebab dia punya ni lah, dia punya sebabnya adalah okay, the median falls to the left of the center of the box and then the right line. Okay, awak tengok right line ni adalah lebih besar daripada left line. Okay, so we can conclude that the distribution is positively skewed. Okay, if the box plot of two or more data sets are graphed on the same axis, the distribution can be compared. So to compare the average, use the location of the medians. To compare the variability, use the interquartile range. Okay, length of the box. Okay, these are the examples for comparing two set of data using box plot. Okay, so a dietitian is interested in comparing the sodium content of real cheese with the sodium content of cheese substitute. So the data for two random samples are shown. So ada dua data kat sini untuk real cheese and cheese substitute. So kita from the data we find the five number summary for each of the data, and then this is how the box plot for both data looks like. Okay, we can say that the first one for real cheese is positively skewed, and the second data is negatively skewed. Okay. And actually, a modified box plot, okay, can be drawn to check for outliers. So, another important point to remember is that the summary statistic, median and interquartile range are used in exploratory data analysis are said to be resistance statistic. A resistance statistic is relatively less affected by outliers than a non-resistance statistic. Okay, so maksudnya kat sini median dengan interquartile range ni tak sensitif terhadap outliers. Okay, outliers ni apabila ada uh, nilai yang terlampau besar atau nilai yang terlampau kecil, kita akan katakan ia sebagai outliers. Okay, the mean and standard deviation are non-resistant statistic. So, ini adalah pengetahuan untuk awak. Sometimes when a distribution is skewed or contain outliers, the median and interquartile range may more accurately summarize the data than the mean and standard deviation, since the mean and standard deviation are more affected in this case. Okay, sebab bila kita cari purata ataupun mean ni, bila ada nilai yang terlampau kecil atau terlampau besar, memang akan mempengaruhi nilai mean yang kita peroleh. Manakala untuk standard deviation juga, sebab standard deviation ni guna nilai mean. Sebab itulah efek daripada mean tu, standard deviation juga adalah dalam kategori non-resistant statistic. Okay. Dia ada hubung kait di situ. Okay, for the next graph is Pareto chart. Okay, sebenarnya Pareto chart ni kalau awak tengok sekali impas, bentuk rupa dia macam histogram, macam bar graph juga. Okay, tapi Pareto chart ni, okay, kita tengok dia is used to represent a frequency distribution for a categorical variable, and the frequencies are displayed by the heights of the vertical bar, which are arranged in order from highest to lowest. Okay, inilah yang menjadi kelainan kepada Pareto chart ni. Okay, so Pareto chart ni kita gunakan untuk categorical variable, and then kita kena susun dulu dia punya frekuensi dalam bentuk okay, frekuensi dia from the highest to lowest. So this okay, let's see the example how to build a Pareto chart. We have data for homeless people. The data shown here consists of a number of homeless people for a number of selected cities. So selected cities ni kita boleh kategorikan dia sebagai categorical variable lah. Okay, construct and analyze a Pareto chart for the data. So number ni adalah frekuensi dia. So city adalah a categorical variable yang kita ada. So let's see, there are 3 steps on how to build the solution to draw a Pareto chart. So step 1 is to arrange the data from largest to smallest according to frequency. So kalau awak tengok kat sini, the largest one is okay, the largest one is the Atlanta. Okay, this is number 1. And then Chicago. Next one is Washington. Third one this is third one. The fourth one is this. And then the third list is for number 5. Okay, so the next step after we arrange the data based on its frequency from ascending to descending order. So the next step is you have to draw and label the X and Y axis. Step 3 is you have to draw the bar corresponding to the frequency. Okay, so the suggestion, when you draw this kind of graph, you have to make sure the bar have the same width. Okay, janganlah sekejap kecil, sekejap besar. Consistent. We have to be consistent in terms of the width of the bar. And then you have to arrange the data from the largest to smallest lah. Okay, according to frequency. And then make the units that are used for the frequency equal in size. Okay. So this is how Pareto chart looks like. Okay. Okay, this is the x-axis. The x-axis is for the categorical variable that we have, city, and then we have the frequency is for the frequency of the homeless people for every city. So this is how the graph looks like from the highest frequency is Atlanta, and then followed by Chicago, and the lowest one is St. Louis. Okay, so if you are asked to build the Pareto chart, jangan tersilap lah, jangan tulis histogram pula. Okay, so this is the Pareto chart. Beza dengan bar graph yang biasa ialah kalau bar graph selalunya dia tak perlu disusun, and then dia tak perlu untuk rapat-rapat. Okay, kita akan just ada, kalau ada space between each bar, it is fine. But then for this kind of Pareto chart, dia adalah from the first bar to the second bar, they are close together. Okay, attached with each other. Some same like histogram. Okay, so next is time series graph. Bila awak dengar pasal time series graph ni, awak kena bayangkan data awak adalah berkaitan dengan perubahan masa dari from time to time. And then, okay, so when data are collected over a period of time, they can be represented by a time series graph. So a time series graph represent data that occur over a specific period of time. Ini adalah maksud dia lah. Okay, so two or more data set can be compared on the same graph, and it is called as compound time series graph. Okay, so compound time series graph ni boleh ada two or more lines on the same graph lah kiranya. So that is the compound time series. Okay, let's see. This is the example on this is a example. Okay, we want to build. Okay, we want to construct the time series graph. Okay, workplace homicide. The number of homicides that occur in the workplace for the years 2003 to 2008 is shown. Draw and analyze a time series graph for the data. So in year 2003, 2004, 2005, 2006, 2007, and 2008. So the year, okay, the time will be our x, okay, x variable, and number is our y variable. Okay, so these are the steps, okay, how to build the time series graph. The first one is draw x and y axis. Step 2, that's why you have to know which one is your x and y variable, because you have to label your graph. Please always remember that you have to label your graph. Okay, graph adalah tidak lengkap tanpa label. Orang tak akan faham kalau awak punya graph tiada label. So always always label your graph. Next, plot each point according to the table. So just follow your table and then draw the line segments connecting adjacent. Okay. This is the time series graph for workplace homicide. Okay, so you can see a slight decrease. Okay, a slight decrease of number of homicide in year of 2004. Okay, from 2003, okay, dia turun tau. 2005 and 2006. Walaupun daripada 2004 tu ada peningkatan sedikit. Nak banding, okay, maksudnya 2005 ada peningkatan sedikit daripada 2004. Tapi kalau kita tengok daripada 2003 ni, trend dia adalah menurun lah sampai 2006. But then, okay, it is increased again in 2007. but it is largest decrease in 2008. Okay, so this what we call as um, time series graph. Nampak macam frequency polygon, but you have to remember frequency polygon kita guna boundaries, okay, and then we connect with values 0, okay, dekat bahagian depan dengan bahagian belakang. So dia connect dengan kita punya x-axis. Okay, but kalau untuk time series graph ni dia tak akan touch kat 0 point lah. Okay, dekat x, kecuali memang dia punya value 0 lah. Tapi kalau tidak, dia memang tergantung macam ni je lah. Okay. Okay. So, the next example is the example for compound time series graph. Okay, ada dua kat sini. So, this graph show the percentage of elderly males and females in the United States labor force from 1960 to 2008. So, it shows that the percent of elderly men decreased significantly from 1960 to 1990, and then increased slightly after that. For elderly females, the percent decreased slightly from 1960 to 1980s and increased from 1980s to 2008. Okay. Yang dalam bentuk ayat ni adalah penerangan nak memberikan kefahaman kepada readers. Okay, so always remember when you construct a graph, you have to make sure that after you construct the graph, you understand the graph. Okay, macam mana nak tahu kita faham ke tak? Apa yang kita buat ialah kalau kita boleh terangkan kembali dalam bentuk ayat. Okay, dalam bentuk ayat ataupun secara verbal. Itu menunjukkan yang kita faham apa yang kita buat. Kalau just buat saja, okay, mungkin memang faham tapi orang lain mungkin tak faham. So, pentingnya sebagai orang statistik ni, okay, selain daripada kita faham sendiri apa yang kita buat, you have to make sure other people will understand what you try to deliver to them. Okay, so ini salah satunya lah. Okay, part graph ni. Okay, next is pie chart. So pie graph are used extensively in statistics. The purpose of pie graph is to show the relationship of the part to the whole by visually comparing the sizes of the section. So percentage or proportion can be used. The variable in nominal or categorical. So a pie graph is a circle that is divided into section or wedges according to the percentage of frequency in each category of the distribution. So bentuknya adalah berbentuk bulat dan setiap section itu boleh setiap section itu dia punya size adalah depending on the degree, okay, from over the 360 degrees. And we also can use percentage, okay, untuk mewakilkan nilai daripada keseluruhan data kita. Okay, so this is the example for pie chart. Okay, so let's see. We have a data of Super Bowl snack foods. This frequency distribution shows number of pounds of each snack food eaten during the Super Bowl. Construct a pie graph for the data. So, awak tengok kat sini, snack ni ada bermacam-macam jenis. And then this is the frequency. So, from the frequency, you have to find the total frequency. Okay, sebab kita nak cari, bila kita nak cari dia punya size, okay, dalam section tu, okay, untuk kita lukis pie graph ni, kita kena tahu, okay, dia punya total frekuensi dia terlebih dahulu. Sebab ini adalah kita punya formula. Okay, bila kita nak buat pie chart ataupun pie graph, sama saja. Okay, first step, since there are 360 degree in a circle, the frequency for each class must be converted into a proportional part of the circle. So, kita tahu nak cari nak cari degrees untuk setiap ini. So, setiap satu ni kita kena convert kepada degree. So, you have to use this formula. So degrees is F over N. N tu adalah total frequency lah sebenarnya. Darab dengan, okay, times 360 degree. So each frequency must also be converted to a percentage. Okay, next, using a protractor and compass, draw the graph using the appropriate degree measure found in step 1 and label each section with the name and percentage. Okay. Maksudnya kat sini, step 1 yang awak gunakan tu, nak cari degree tu, itu kegunaannya adalah untuk lukis. Untuk lukis tu, nak tahu daripada 360 tu nak bahagi berapa setiap section tu, berapa degree, itu adalah for the purpose untuk melukis. Step 2, yang awak kena cari percentage tu, that is for the purpose of labeling every section yang awak dah lukis. Okay, so kat sini saya tak include lah formula percentage. Okay, saya harap semua tahu formula percentage. Sama je macam formula degrees ni, tapi untuk percentage F over N times 100 degree. 100 degree, sorry, 100%. Saya pun dah salah. Okay, saya ulang. Percentage is F over N times 100%. Okay, so daripada situ awak akan dapat lihat awak ada, okay, awak akan dapat percentage untuk setiap satu tu. So, kalau macam ni, ada 1, 2, 3, 4, 5. Snack ni ada 5 jenis. You have to repeat the calculation for 5 times. Okay, for each snack type. Okay, kena cari percentage untuk popcorn, snack nut, pretzel. Sama juga dengan degree tadi. You have to find 5 untuk 5 section kan, so jadinya kena 5 kali lah, dia kena F over N darab 360 dapat snack nut. Lepas tu kita tengok lagi frekuensi untuk popcorn berapa pula, buat lagi sekali dan seterusnya. Okay, so next we have stem and leaf plot. Okay, stem and leaf plot is a method of organizing data. Okay, we want to organize data, and it's a combination of sorting and graphing. It has the advantage over a group frequency distribution of retaining the actual data while showing them in a graphical form. So a stem and leaf plot is a data plot that uses part of the data value as the stem and part of the value as the leaf to form groups or classes. So this is the example for stem and leaf plot data. Okay, stem and leaf plot. Okay, this is the data. So at an outpatient testing center, the number of cardiograms performed each day for 20 days is shown. So this is the number of cardiograms for each day for 20 days. Okay, so when you want to construct the stem and leaf plot, you have to arrange the number in ascending order. Then you have to separate the data according to the first digit. So we can see that, okay, the first one, okay, 0, 2. And then we have 1, 3, 1, 4. Then we have 2, 0, 2, 3, 2, 5. We have 3, 1, 3, 2, 3, 2, 3, 2. Banyak pula 3, 2 3, 3, 3, 6. Then we have 43, 44, 45. And then 5, 1, 5, 2, and 5, 7. Okay, this is how we separate. And then a display can be made using the leading digit as the stem and the trailing digit as the leaf. Okay, this is how it looks like. So this is your stem and leaf plot. Okay, but you have to remember, okay, if kalaulah tiba-tiba untuk digit, okay, untuk 3, okay, kita kan ada 012. Untuk 3 ni tak ada apa yang tak 30, tak ada 31, tak ada sampai 39, memang tak wujud nombor tu. Just leave the, okay, just left out the leaf part blanks. Okay, tapi awak tetap letak 3 ni. Tapi dekat bahagian trailing tu, biarkan kosong. Bukan letak angka kosong ya. Kalau awak letak angka kosong, dia akan jadi 30. 30. Tapi leave it blank. Okay. So the distribution peaks in the center and there are no gaps in the data. For 7 of the 20 days, the number of patients received cardiogram was between 31 and 36. Okay, the plot also show the testing center treated from a minimum 2 patients to a maximum 57 patients in one day. Okay. And then, if there are no data values in a class, you should write the stem number and leave row blank. Ni macam saya cakap lah. And do not put a 0 in the leaf row. Tu apa yang saya sebutkan tadi. Okay. Itu adalah stem and leaf plot. Okay, if you have 2 data and you want to compare the data using stem and leaf plot, so we call it as a back-to-back stem and leaf plot. Okay, this is the example that we have. Okay, the number of stories into selected sample of tall buildings in Atlanta and Philadelphia is shown. So you have to construct back-to-back stem and leaf plot. Okay, so the first step is you have to arrange both data in this set in order. Okay, and then construct stem and leaf plot using the same digit as stem. Place the digit for the leaf for Atlanta on the left side and the digit for the Philadelphia on the right side. Okay, so tengok kat sini. Okay, yang tengah-tengah ni kita panggil dia sebagai stem. And this one is leaf for Philadelphia. And then this one is the leaf for Atlanta. Okay, this is back-to-back stem and leaf plot. Cara dia sama je macam tadi, cumanya stem dia dah jadi kat tengah-tengah, leaf dia ada 2 cabang sebab dia nak bandingkan 2 data. Okay, so we compare the distribution. The buildings in Atlanta have a large variation in the number of stories per building. Although both distributions are peak in the 30 to 39 stories, okay, story class, Philadelphia has more buildings in this class. Okay, walaupun dia punya peak, kalau tengok kan, distribution ni peak dia dekat sini sama. Sini pun peak dia dekat sini. Tapi Philadelphia ni lebih banyak daripada Atlanta. Atlanta has more buildings that have 40 or more stories than Philadelphia. So, kalau awak bandingkan pula, okay, untuk 40 stories and above, dekat Atlanta ni lagi banyak nak banding dengan Philadelphia. Sebab dekat Philadelphia ni lagi banyak dekat bahagian 30 to 39 stories. Okay, so kita dah tengok kelima-lima jenis graf tadi. Okay, bila awak belajar tentang graf, okay, awak kena tahu some time, okay, there are misleading graph. Okay, why this happen? Okay, mungkin dia punya misleading tu mungkin dia gunakan orang kata skala yang salah. Okay, dan tujuannya adalah memang untuk mengelirukan readers. Okay, sorry. So 2.4 is about the misleading graph. So graph give a visual representation that enable readers to analyze and interpret data. However, inappropriate drawn graph can misrepresent the data and lead to false conclusion. Okay, for example, a car manufacturer X stated that 98% of the vehicle it has sold for the past 10 years was still on the road. The ad then show a graph similar to the one in figure, okay, the next figure. So the graph show the percentage of the manufacturer automobiles still on the road and the percentage of its competitor that's still on the road. Okay, is there a large difference? Okay, not necessarily. Okay, dia macam ni. Okay. Okay. Alright. Kalau awak tengok the first graph, okay, the first graph nampak macam perbezaan yang banyak antara manufacturer ni dengan dia punya competitor. Okay, tetapi sebenarnya graf yang di sebelah kiri ni adalah sama je dengan graf yang di sebelah kanan. Apa yang membezakan ia menjadi sebegini kerana dia punya skala. Okay, skala yang bahagian belah kiri ni, graf belah kiri ni, dia tidak bermula daripada sifar. Okay, dia terus daripada 95, 96, 97 sampai 100. Okay, sebab tu nampak perbezaan ni macam ketara. Tetapi, okay, untuk graf yang di bahagian kanan ni, skala dia sebenarnya lebih bagus. Sebab dia bermula daripada sifar, 0, 20, 40. Okay, setiap 1 cm, okay, setiap 1 cm, contohlah 1 cm mewakili 20 bilangan dia. Okay, dan bila dia kat sini sebenarnya perbezaan tak ketara pun. Okay. So, we call this, okay, this is a truncate. Okay, truncate scale. Okay, so this is a graph of automakers claim using a scale from 95 to 100%. Okay, and then this is for graph scale from 0 to 100. Okay, changing the unit at the starting point on the y-axis can convey a very different visual representation of the data. Okay, it is not wrong to truncate the axis. Okay, so apa yang dia buat tu nama dia ialah truncate axis. Okay, many times it is necessary to do so. Sebenarnya ada je keadaan yang kita perlu buat cara yang truncate tu, tak bermula daripada sifar tu. However, the reader should be aware of this fact and interpret the graph accordingly. Do not mislead if an appropriate impression is given. Okay, maksudnya kat sini reader perlu ada pengetahuan lah untuk betul-betul memahami graf yang terpapar. Okay, sebab kalau kita tak faham, okay, boleh jadi kita akan cakap yang baguslah jenama, okay, yang warna biru ni kan, baguslah dia ni, lepas 10 tahun banyak lagi atas jalan. Okay, tinggi persen dia, padahal dia tak tengok pun y-axis ni macam mana. Sebenarnya beza dia satu-satu je ni. Okay, so pengetahuan untuk memahami graf tu sangat-sangat penting supaya apa yang dipahami tu tak salah lah. Okay. Let us consider another example. The project required fuel economy in miles per gallon for general motor vehicle is shown. So in this case, an increase from 21.9 to 23.2 miles per gallon is projected. Okay, awak tengok graf ni. Okay. Again, example of truncate scale. Okay. Kalau kita tengok ini tadi, kalau kita guna scale, okay, memang dia tak bermula daripada sifar. Tapi, okay, untuk graf yang pertama ni, dia gunakan setiap cm mewakili 5. Okay, but the second graph dia guna truncate. Okay, dia buat 21, 22, 23 sampai 24. Bila kita tengok yang graf pertama ni macam just very slight increase. But if we see the second graph, ada macam perubahan yang agak peningkatan yang agak ketara. So, another misleading graph technique. Okay, so tadi, the first part is about the truncate scale. So, daripada truncate scale tu, boleh menyebabkan orang salah faham tentang graf yang mereka lihat. So, another misleading graphing technique sometimes involve exaggerating a one-dimensional increase by showing it in two dimensions. For example, the average cost of a 30-second Super Bowl commercial has increased from 42,000 in 1967 to 3 million in 2010. So the increase shown by the graph in figure 2.19a represent the change by a comparison of the height of the two bars in one dimension. The same data are shown two-dimensionally with circle. Okay, notice that the difference seems much larger because the eye is comparing the areas of the circle rather than the length of the diameter. Okay, note that it is not wrong to use the graphing technique of truncating the scale or representing data by two-dimensional picture. But when these techniques are used, the reader should be cautious of the conclusion drawn on the basis of the graph. Okay, this is the example. Dia nak bezakan peningkatan harga pada untuk Super Bowl ni, Super Bowl commercial. Okay, ni harga pada 1967. Ini harga pada, ini cost pada 2010. Okay, kalau bila dia gunakan two dimension, okay, of ni dia guna circle kat sini, nampak perbezaan lagi ketara. Okay, so kat sini boleh jadi orang salah faham. Okay, benda ni tak salah, tetapi reader sendiri, orang yang tengok tu yang mungkin tak faham dan salah faham. Okay. So, another way to misrepresent the data on a graph is by omitting labels or units on the axis of the graph. Okay, to represent data on graph is by omitting labels or units. Okay, the graph shown in figure 2.20 compares the cost of living, okay, economic growth and population growth of 4 main geographic areas in the United States. So since there are no numbers on the y-axis, very little information can be gained from the graph except a crude ranking of each factor. So there is no way to decide the actual magnitude of the differences. Okay, so as you can see, okay, dia nak bezakan, okay, 4 tempat ni. Dia punya cost of living, economic growth, population, crime rate, okay. Tapi dia tak letak orang kata scale pada y-axis, tak ada numbers. So akan berlaku represent of the data jugalah bila kita tak tahu the real values of the real values yang diwakili oleh kita punya graph. Okay, tetapi ada pihak-pihak yang suka menggunakan teknik-teknik misleading ni, okay, untuk orang kata nak gain kepercayaan orang, untuk nampak dia dapat, orang kata untuk nampak dia punya score lagi baik, okay, macam kalau dalam advertisement, okay, so dalam ataupun dalam akhbar, dalam berita-berita, figure, okay, sama ada dalam bentuk numbers, percentage ke ataupun dalam segi grafikal ni, okay, banyak disalah gunakan, okay, untuk tujuan mengelirukan orang yang membaca. So sangat penting untuk kita faham, okay, untuk kita faham kaedah sebenar. Satu, kita kena faham macam mana nak buat graf tu, and then kita kena tahu macam mana nak faham apa yang terkandung pada kita punya graf. Okay, so all graph contain a source of for the information presented. Okay, so sepatutnya graph ni ada information yang penting yang nak dipaparkan. So the inclusion of a source for the data will enable you to check the reliability of the organization presenting the data. So this is the summary of the data that you have learned. Okay, the one is the histogram, polygon, and OGIF. Okay, we use the frequency distribution, and then this one for OGIF we use the cumulative frequency. Okay, this part is the Pareto chart, show frequency for nominal or qualitative variables. The time series graph, okay, kita tengok trend over times. Okay, perubahan sesuatu tu. And then this is pie graph to show the relationship between the parts of the whole. Okay, so ini akan kita akan tulis dalam bentuk percentage. Okay, so these are all about the graph and also the misleading of the graph. So saya harap awak semua dah boleh bezakan jenis-jenis graph yang awak dah belajar since last week. Okay, and then refresh balik macam mana, apa tu frequency distribution, macam mana nak cari cumulative frequency, and then daripada macam mana nak bina group, nak bina kelas untuk kita punya data, macam mana nak cari class limit, class width, and then upper boundary, lower boundary, and then how to find midpoint. Itu adalah yang anda telah belajar pada minggu lepas. Okay, and then yang ini adalah sambungan dan sedikit conclusion daripada overall mengenai frequency distribution and graph. Okay, saya ada sertakan tutorial, okay, yang saya dah upload. Okay, this is your tutorial 3. Ada altogether is 7 question. So all question you have to understand the data, and then you have to construct the graph based on the question given. Okay, so we will discuss tutorial 2 and tutorial 3 on Monday. Okay, I hope that you all can attend the class. Okay, so we have a lot to discuss and a lot to go through one by one, okay, for this topic. So see you on Monday. Thank you.